In this video I'll be completing questions from the November 2014 Paper 2 Calculator Aloud. For any pupils not from Bryn Hafren, this paper has been made using the legacy specification for maths, taking any content from the foundation and higher tier as it was, the content then that's applicable for the intermediate tier. Question 1. We've got, zoom in a bit for us, we've got a circular quantity that is the appropriate estimate for each of the following. Weight of a male year 11 pupil. We've got 65 kilograms, 65 grams, 65 milligrams, or 65 kilometers, which is obviously a distance. Remember my advice that a kilogram is a bag of sugar. And so about 65 kilograms would be appropriate for weight of a male year 11 pupil. Capacity of a teacup. Remember that a can of Coke is 330 ml or 330 centimeters cubed, because a centimeter cubed and a milliliter are the same quantity. So to start with, I'm going to get rid of that because 250 centimeters squared is an area. And then I've got 250 litres, which is quite a significant amount of water. 250 millimeters cubed, so I'm between 250 centimeters cubed or 250 millimeters cubed. Another way of remembering centimeter cube is like a dice. A dice you just get in a standard board game. So about 250 of them would fit into a teacup. Distance from Dover to Calais, I've got meters, which is like 41 meters is 41 paces, 41 centimeters, just a bit bigger than your standard 30 centimeter ruler, and then we had 41 kilometers there, which is the one we're interested in. 41 millimeters is obviously tiny, so 41 kilometers. And width of an ordinary house window, that's 210 meters. That's quite long distance. 210 centimeters, which is just over 2 meters. 210 millimeters, which would be really small, 21 centimeters for a window, or 210 kilometers, which, as we said, would be used to measure distance between two cities. So 210 centimeters is the one we'll go for there, same as 2.1 meters. Write down the special name of the straight line shown in each of the following diagrams. This here is a tangent, and this is a radius. The two lines that we also have to learn that haven't been given here is the diameter, which runs right the way through the middle and is equal to 2 radius, and is also then the chord, which just joins 2 points on the circumference and doesn't go through the middle. Question 3. Question 3 is on posting letters. When we post our letters, we've got a choice of first class or second class, which basically determines how quickly a letter is going to get there. We've got weight categories then to determine whether, of course, within the small and large letters, how heavy it is, you pay more postage. And then at the bottom we've got the width measurements for what makes a letter large or normal. Now, interestingly here, we'll actually find out that we don't need to use this information at the bottom, because all of the questions talk about weight, and only weights up to 100 grams can be classified as a small letter anyway, which is why we've only got 60p and 50p there and nothing in these three entries. Okay, Mark is going to post 2 large letters each weighing 230 grams, and he buys 2 first class stamps. How much does Mark pay altogether? Well, if they're weighing 230 grams, they're going to be in this class, 101 to 250, and large letters are £1.20 first class, £1.10 second class. He said he wanted to go first class, so that's 2 times £1.20, which is £2.40. Camille posts 3 large letters. The weights of the letters are 75 grams, 400 grams and 650 grams. How much cheaper is it for her to use second class stamps rather than first class stamps? Well, if I work on the first class first, all the letters are large, so I've got the 75 gram one would come here, 90p. The 400 gram one would be in the 251 to 500 category, £1.60. And the last one then, the 650 grams, would be this one, £2.30. Now when you type into the calculator, you've got to be careful because of course we wrote 90p there and now we're going into a pound signs. So I'm actually going to put 0.90 into my calculator to deal with sort of the pound notation for pennies. Plus £1.60 plus £2.30 all comes to £4.80. And if I take the figures from the second column now for second class and write that here, the second class, our 75 gram is 69p, our 400 gram is £1.40, and our 650 gram is £1.90. Add all these up in a calculator and it comes to £3.99. Do a subtraction because they wanted to know how much more, and that'll give you 81 pence. Rebecca has a letter that weighs 550 grams, and then it gives us the length, the width and the thickness. Now that's almost obsolete information because if it weighs 550 grams it cannot be small. It has to be a large letter regardless of the size of it. So there's only a case of considering a £2.30 first class or a £1.90 second class. She only has 2 £1 coins. Does Rebecca have enough money to post her letter? Show all your work and give a reason for your answer. Well, as it's 550 grams, that's £2.30 first class or £1.90 second class. If she's only got 2 £1 coins, she can't afford that. She's 30p short. But she can send her letter second class, and of course she'd have 10p change. We're not asked to calculate the change, but it does just help to show that we recognise that she's got 2 £1 coins. Describe in words the rule for continuing the following sequences. Now this sequence is decreasing, and the temptation is to think that it's subtraction. 48 take away 36 gives 12, and 12 take 9 gives 3. We're not taking away the same amount each time, so it's unlikely to be a subtract. What we're looking at in a sequence when it does this is actually a division. A divide by something. And if we look at the terms in the middle here, 12 and 3, I know dividing by 4, 12 divided by 4 makes 3, and I can check that out. 48 divided by 4 does give me 12. And if I type 3 divided by 4 in the calculator, I get 0.75. So I know the rule is divide by 4. Likewise on this one, this is increasing, but this is going up by 6, and then by 18, and then by 54. So it's not going up by a nice, easy to spot amount each time. And when this happens, it's going to be multiply by something. And if you look at 3 becoming 9, well that's 3 times 3. And then 9 times 3 is 27, and 27 times 3 is 81. So it is multiplied by 3. Then write down the next 2 terms of the following sequence. This decreases by 1. This decreases by 3. This decreases by 5. And then 7. So my next sequence will be decreased by 9. 9 take 9 is nothing. And then decrease by 11, nothing take away 11 is minus 11. Then a simplified question, 3a plus 6a is 9a, take away an A gives me 8A. And then an odd question, it's just getting us to form an expression. Jean rolls a dice many times. She gets a score of 3 on 7 occasions and a score of 4 on n occasions. They're not telling us how many times she got a 4, but then it asks us to write down the total score of these 3s and 4s in terms of n. Well, the 3 times 7 bit would be no problem. The 7 times she gets a 3 would give her 21. And I'd like to do the same now by doing 4 times the number of 4s she gets, but they don't tell us. It's just 4 times n. And if I've got that situation, I can't do anything other than write 4n. So her total score would be 21 plus 4n added together. On a question like this, it doesn't really feel like we've done anything, because we're expected, we just expect to have to solve or find the value of n, but that is it. We've formed an expression. Question 5. It's an OCW question. A quick scan sees that we're working with hours and money. It's a question about pay. So I want to explain myself clearly using bullet points whenever I work out or type into the calculator. And I also want to make sure that I put a unit on every number that I write down. Helen works in a shop. Her normal working week is 35 hours. She's paid £8.74 per hour. When she works for more than 35 hours, she's paid a higher amount for each extra hour she works, which is informally known as the overtime rate. Here's her timesheet for 1 week when she was paid a total of £358.34. If I add these up, 8 plus 7 plus 9 plus 8 plus 7, she actually works 39 hours in this 1 week. And she should have only worked 35. So my job is to work out the amount she's paid for each extra hour. So what I'm going to do to start with is say 8 plus 7 plus 9 plus 8 plus 7 equals 39 hours, which is 4 extra hours worked. I'm then going to work out what she should usually be paid. She is usually paid 35 hours times £8.74, and remember your pound sign, and 35 times £8.74 comes out to be 305.9, which of course, if we leave it like that, that's not good. We need to put the O on as well, because we have 2 decimal places with our money. Now, because she was paid £358.34, if I take 305.90 off that, 358.34 minus 305.90 comes to £52.44, and we've just calculated her extra pay. Now, £52.44 overtime was for 4 hours extra, and 52.44 divided by 4 gives £13.11 per hour. The following solid shape is made up of cubes with sides of 1 centimetre. So these are 1 centimetre cubed things, and this is what I said earlier, that's about the size of a dice. So imagine making this solid out of dice. What is the volume of the shape? Give the units of your answer. So this is a count the cubes question. If you can see that that cube could fit into that gap in there, you'd have 2 rows of 6, and it makes it really easy to count that we've got 12 cubes, and we should put centimetre cubed on there then to get the other mark, because it asks for the units of the answer. Laszlo came on holiday to Wales from Italy, and then it says about what Laszlo changed his money. Now, we learn the home and away diagram to help us here. like so. We multiply when we go away and we divide when we come back. But this is an odd one because it's from an Italian person's perspective. He's coming on holiday to Wales from Italy. So for him, Italy is home and his holiday away is Wales. He changed 1550 euros, which is his home money, into pounds, which is his foreign money. And the rate of exchange was €1 equals 0.84. So I'm going to take the 1550 and times it by the rate 0.84 to find out how much British pounds he received, which is £1,302. During his stay, Laszlo spent £798 on his accommodation. He used the same exchange rate to convert this amount into euros. Well, he wants to work out what the foreign money was worth in his home money. So that's 798 divide by the 0.84. And that comes to £950. Each girl in year 8 chose her one favourite sport. 1 out of 7 of the girls chose football, 4 out of 7 of the girls chose volleyball, and then the rest of the girls, 30 of them, chose hockey. How many girls are there in year 8? Now, we can't find a seventh of the amount or 4/7 of the amount because we don't know what the amount is. That's the actual question. If we make our link between finding fraction of a number and ratio, I'm going to draw 7 boxes to start with. And underneath I'm going to write an F there for football because 1/7, so one of the groups of 7 football, 4/7 chose volleyball, and so I know then that there must be 2 groups left who chose hockey. The rest of the girls, 30 of them chose hockey, so these 2 groups add up to 30, which means that there must be 15 in each group, so that the 2 add up to 30. And if there's 15 in each of those, there needs to be 15 in all the groups to make the proportion work. So I need to work out what 7 15s are, and that comes to 105 girls. Got a pie chart now. Type of mobile phone owned by each of 240 pupils was recorded. The results are summarised in the table below. Remember, when we're working out our angles with a calculator, I like the fraction button method because that can be typed into the calculator all in one go using the button. It looks like that. And if we do that, this angle comes out to be 150. When we do 64 over 240 times 360, that'll come out to be 96 degrees. 40 over 240 times 360 will come out to be 60 degrees, and 36 out of 240 times 360 will come out to be 54 degrees. If you add all those up, they come back to 360, which is great. We start off now by drawing ourselves a radius, so we give ourselves a point of reference to start measuring our angle. And when we've got that on, we can then draw our first angle in, which is going to be the mobile phone type A, 150. Now I'm going to put the protractor on the line like so, so that 0 is going along the radius I just drew and my dot is at the middle. And I'm going to come all the way around the outside scale until I hit 150. And then I'm going to join the edge of the circumference using the dot as a guide. I don't really want to extend my line out there, I just use it as a guide, and I end up with my first section, and I'm just going to write A in there. I'm not going to write any of the numbers given, just the category. Now my next one to draw is 96 for B, and I measure now from the last line that I just drew. So I've lined them up like that now with 0 going along that line. And I come all the way around to 96 on the outside scale, and that's B. And then I've got to draw 60 next. So for C, and then the last section is going to be other. Now a little measure is worthwhile. I measure this in here now, and it comes out to be 53. Now I was trying to make 54, but it doesn't mean that I've done it wrong. Right, a degree is so small that it's hard to get exactly right, and the examiner will let you have 2 degrees either way of where it should be. So you should be concentrating on using like a nice thick pencil and all that to be as precise as you can. But if you're only a degree or 2 out by the time it comes to measuring your last piece of pie, then you're absolutely fine. You're going to get the full marks. An electricity bill now. Pretty standard question. We've just got to fill in the blanks on this. So we've got units used, the amount for units, add on some tax, show the total, and we're also owing a little bit from our last bill. How much are we going to be paying? Work here first with these 2 units measurements. Find the difference in those two. And we come out with 1364. So doing a takeaway there gives us 1364 units. Now we need to be careful because these need to be times. Okay, so I'll put the 1364 times 13.3 in the calculator. As you can see here now, we get a very large number. Now that is in pennies at the moment, 18,141.2 pence, because that was in pence. So at this point now, I'm going to divide by 100 to turn it into pounds. But even that doesn't look right because I got 3 decimal places. Now if I just chop off that 2 there, that looks better, £181.41. And I can do that because the 2 is below 5. So in here now, £181.41. VAT is at 5%. So I'm going to do 0.05 times 181.41. VAT is a tax. That comes out to be, again, quite a large number there. That is in pounds now, but it's £9.07. The 0 doesn't affect the 7, so it's just £9.07. Total charge then is these added together, which is £190.48, and she owed some money from a previous bill as well, £21.15. So we can add these 2 together. You can use the calculator, of course, and we get £211.63 for that bill. Okay. Next we've got a scatter graph, and questions on the other page then are about the scatter graph, and particularly something that we really see here. They're bringing mean into this. When they ask us to draw a line of best fit, normally it's only worth 1 mark, but we're told the mean of the x is 32. We've got to calculate the mean of the y and then draw a line of best fit, and that's now worth 4 marks. It's the marks have gone up significantly for just doing this mean thing. Let's have a look first at plotting the scatter diagram. It's a lovely scale. We got 1 box for 1 on both axes, so there's no problems there. We just plot these as pairs, making sure we go across first on the x20 and then up to 16. So 20, 16 is here. Then it's 36, 32. Which is there. You've got to be precise on this. They will check every point. And then 44, 40, 22, 20, 38, 34. It's a little bit lower there. 40, 32. So a reminder, I say it a few times, you must use pencil. I'm only using pen so that you guys can see this on the video nice and clearly. And then 8, 6. Just there. Okay, so that's what I'm looking at there. There's a nice easy question over here for part C. What type of correlation does the chart diagram show? Well, it's positive because it's climbing. It'd be negative if it was coming down this way, and if the points were scattered everywhere, there'd be no correlation. But this is positive. Now it says the mean of the x values is 32. Now they've got that. You find the mean by adding up and dividing by how many there are. So they've done 20 plus 36 plus 44 plus 22 and so on, and then divided by 8 at the end, and they've got 32. So we're going to do the same for the y's. We're going to do 16 plus 32 plus 40 plus 20 plus 34 plus 32 plus 44 plus 6. Do some adding up now. Add all these numbers together. And they all come to 224. And if I do 224 divided by the 8 pieces of data there are, come out with 28. Now what that means is that there's a mean point that's 32.28. That's like an average point for the results x and y in this case, and that can actually be added on as well to this graph at 32.28. So I come across the 32 up to 28, which is just here. Now I'm going to circle this one, and I'm going to put a circle around it because I want it to stand out. Because for my last mark in this section now, where it says and then draw a line of best fit, the usual rules of lines best fit apply. I'm not to start in the bottom corner. I'm only to draw the line between the points given. I'm trying to get the same above and below. But because I know the mean point, my line has to go through this point as well. So I'm going to go for something like that. And that then would be my line of best fit. Do not continue down to the axis on a line of best fit. Part D then says, use your line of best fit, find an approximate value of y when x is 25. Well, when x is 25, that's here, I can draw up to my line, like so, and then I can come across, and I'm just above 21 there, so I should say 21.5 really. That's what I'm going to put, 21.5. But you might have a little bit of a different answer to me. You might have 23 or 20, and that's fine because of course we approximated where our line of best fit was. If your line was a tiny bit steeper than mine, you're going to get a different reading off this, and that's absolutely fine. Nothing to worry about. Question 12. Decrease 7,800 meters by 23%. I think our favourite method is to go the long way. 0.23 times 7,800 comes to 1794, and so if we're doing a decrease, we'll do 7,800 take 1794, which we'll use the calculator for because it's paper 2, and that's 6,006 meters. Now the alternative way of course is to say, well, at the beginning then we had 100%, but we're now cutting off 23%, which leaves me with 77%. So if I turn 77% into a decimal and times by 7,800, you come out with 6,006 in one go. Either of these is absolutely fine, whatever you prefer. Thomas and Rita share £27 in the ratio 1 to 8. Calculate Rita's share of the money. So in our box method, that's what the piles look like. 9 piles altogether. 27 divided by 9 is 3. So it means there's £3 in each pile. I won't bother writing them all in. Thomas just gets £3, and Rita then gets 8 lots of £3. So she gets 24. A little bit of a logic puzzle, question 13, way easier than it looks. The diagram shows 4 identical large square tiles and 6 identical small square tiles. Now, the information given here is I got sort of 2 large boxes and a small box adding up to give me 26. So I'm going to write L, S, L along the side because I know large and large adds up to 26. Down the side here I've got large, small, adding up to 30. And the question is, find the length of one of the large square tiles you must surely work in. If I look at a comparison on this, LSL adds up to 26, LSLS adds up to 30. Basically, on the vertical, you've got an extra small side, and the difference then between the 30 and the 26 is 4. So 30 taken with 26 is 4, which means that these little lengths S must be 4. 4 and 4. And likewise the S up here would be 4. Now if that's 4 and the whole thing's 26, 26 take away 4 is 22. And because you've got 2 identical large ones then, half that and get 11 centimeters for a long side. Calculate the value of X. Now we do have a pentagon in there with 5 sides, and a temptation could be to use this method where we split our pentagon into 3 triangles, 180, 180, 180, so we know there's 540 in the middle. But because this question is working with exterior angles, it's a lot nicer because exterior angles always add up to 360 because you were always just going around the shape fully. Now I've got some algebra in here and I've just got to calculate the value of X. This is one of those questions where we form and solve our own equation. If I go around the outside adding up everything I've got, 3x plus 2x plus 38 plus x plus 34, I know they all add up to 360. I can collect my x's to give me 6x, add 38 and 34 to give me 72, and that equals 360. I formed myself a little 2-step equation. If I drop the 72 to start with, I end up with 6x being equal to 288, and then I can divide 288 by 6 to see what the value of X is. 288 shared by 6 comes out to be 48 degrees. That's all it asked for, calculate the value of X, but of course that means X is 48 there. That means 2x, this angle must be 96 because it's double, and then this one is triple 48 as well, 144. But it doesn't ask us to actually work out the size of all the angles. We've got trial and improvement next. Solution to the equation x cubed minus x minus 10 equals 0 lies between 2 and 3. Use a trial and improvement method to find the solution correct to 1 decimal place. Now, when the WJC give you 0, your answers flip between negative and positive because we're trying to make 0. And anything negative is too small, and anything positive then is too big. That's a useful little thing to remember. Now you know our advised method is we write down all the numbers we could try. We're not going to try them all. All the way down to 3.0. We're going to pick any when we start. Starting in the middle is normally a good plan. So I'm going to go for 2.5. Now it's x cubed, so that's 2.5 cubed, minus x, so minus 2.5, minus 10. We put them all into the calculator using the cube button, and that comes out to be 3.125. Now bearing in mind I'm trying to make 0, that's too big. Remember now, there is no point in trying any of these numbers because If 2.5 was too big, then 2.6, 2.7 and all that's going to be too big as well. So I'm going to drop it down a bit now. I'm going to try 2.3. 2.3 cubed minus 2.3 minus 10. Pop them in. And this one now gives me minus 0.133, and that's too small. So I'm going to put a line through those three because there's no point in trying those three. As soon as I now complete this with the 2.4, I'm going to earn myself 2 marks because I'll have trapped it between two values. I'll show you what I mean now when I've put in my last trial. That one comes to 1.424, which is too big. Okay, I've trapped it because I'm going small to big, and I'm going to put a little cloud around those two because that's important. I know that 2.3 gave me too small and 2.4 gave me too big. Alright, so I'm not interested in a 2.5 one either anymore. Now then, last thing I'm going to do, I need to decide, am I going to pick 2.3 or 2.4? And it's not the case of just picking 2.3 because it's closer to naught, right? We've got to prove that it's the sound thing to do. So the last trial we should make is whatever number is in the middle of 2.3 and 2.4, and that is of course 2.35. So we plug him into the calculator as well. And we come out with 0.627875, which is too big. And I'm going to put a little cloud around that as well. Now that gives us our third mark out of 4 at the moment. The last thing we have to do now is pick either 2.3 or 2.4, and you remember our cheats way now, right? We got small, big and big clouded. Ignore that big because we only want the ones we trapped to start with, plus our midpoint. Small, big, big. Small is the odd one out, and small goes with 2.3. So I'm going to write down x equals 2.3, and that'll give me all the marks. Now why that works is if I drew a little section of a number line, this is 2.3, this is 2.4, and this is 2.35. 2.3 was too small, 2.4 was too big, and 2.35 was also too big. Now that means that if I was going to carry on guessing numbers, I'd pick this section here. Alright, because obviously I'm trying to trap it again, just keep going, going, going until I hit 0 bang on. But whatever number lies in this bit, because it's below the 2.35, it always rounds down to 2.3. So for instance, you could be doing like 2.3 30241, but to one decimal place it's always going to be 2.3 because that 3 is below the 5. Now you don't have to do that at all to get the mark, but look, small, big, big, pick the odd one out, and you can do that just from your workings up here. Okay, question 16. You'll be assessed on the quality of your written communication in this question. So this is OCW. So there's 10 marks altogether, and it's going to be 8 marks for the maths and 2 marks for communicating. Now it's a little bit of an odd one, this one, because there'll be units you haven't seen before, and in fact I hadn't heard of them either, but it's just a real life problem that they're trying to get us to solve by giving us some facts. So radiators are used to heat rooms. Guidance from the internet for calculating the size of radiator needed to heat a room is as follows. Now you can have a quick read of these yourself, but you'll notice the way it's written is giving you sequential steps of what to do, of how to do it. And BTU then in these new British thermal units, that when we know, right, how many BTU we need, we can decide whether we get a mini, small, standard or super radiator. We're given information down the bottom about dimensions of a room, the dimensions of a window, and that he only wants to buy 1 radiator, and we then need to make a suggestion of what Griff buys. Now, you've got a nice blank page over the other side of this to write all this out. So I'm just going to put the maths down on here now, so that I can keep it all on this page. Step 1 says calculate the volume of the room in meters cubed. Now that's using this information here, the 3 dimensions on Griff's room. So I'm going to do 2.4 times 12 times 8, because obviously volume of a cuboid are those 3 dimensions multiplied together, and that comes to be 230.4, and that's meters cubed. And that first bit, like the success criteria, if you will, is done. Allow 50 watts per 1 meter cubed. So for every 1 meter cubed, we got 50 watts. So I'm going to times that by 50 now. And we come out with 11520, and that's watts. Check if the window area is greater than 3 meters squared. If so, increase the total number of watts by 11%. So we work with the area now, the window, 1.7 times 1.8. See what comes out. Area, of course, length times width. Comes out to be 3.06, so it is a little bit bigger than 3. So with the 11520, I need to find 11%. Which is 1267.2, and that needs to be added on because I need to increase like this. So add it on to your original, and that gives me 12787.2 watts still. And the last bit then, it says, I don't like this number because it's confusing with pi, but of course it's 3.412 there, and pi is 3.142, so they are different things. But 1 watt multiplied by 3.412 gives a measure in British thermal units. So if we take this number 12787.2 times it by 3.412, we come out with 43629.9, and then that'll be BTU. Which radiator would you suggest that Griff buys? Now, if we got 43,629, we can look in our table. Well, the mini is too small, the small is too small, and the standard then, 45,000 BTU, is kind of just above that. So we'll go for standard. And our reason would be, of course, for all the OCW marks, our reason would be 45,000 is just sufficient for that. Now I've been a little bit slack here. I haven't actually put units on everything, so I wouldn't be getting OCW. For instance, here 3.06 was meters squared for the window and things. So if you want me to check that when you come back after Easter, then I can have a look at that for you. Question 17. The nth term of a sequence is 3n squared minus 25. Evaluate the 40th term of the sequence. If n is 40, then I'm going to work out 3 times 40 squared, take away 25. You can type that into the calculator in one go. 3 times 40 squared minus 25 is 4775. Write down the nth term of the following sequences. This one goes up in 12s, so I'm going to write the 12 times table underneath the first few terms, and I'm going to start by writing 12n down. Now if I look here, how does 12 become 7, 24 become 19 and all that? Well, you take away 5. 12n take away 5 is the nth term. Now we've got a sequence that's going down now, 48, 46, 44, 42, and it's going down by 2 each time. But if I write the 2 times table underneath and start thinking about 2n, there's not the same gap. It's 2 plus 46 makes 48, but that doesn't work for the next one. because 4 add 46 makes 50. And what's wrong here is I need to reflect the fact that my sequence is decreasing, and so I actually consider minus 2n. If I have a look now, how does minus 2 become 48? Well, you add 50 on, and if you do minus 4 plus 50 as well, you get 46. So minus 2n plus 50 is our nth term. You might see that written as 50 minus 2n in some cases, but minus 2n plus 50 is absolutely fine. E-reader, electronic book. The screen of the e-reader measures 152mm by 102mm with measurements given correct to the nearest millimeter. Calculate the greatest possible area of the screen and give the units of your answer. This is a bounds question, and the clues are greatest possible, or it could be least possible, and the idea of this given to the nearest. Now, if I'm dealing with 152 to the nearest millimeter, well, if I add a millimeter on there, that's 153. Take one off there, 151. Remember my bounds then are these halfway points between these two numbers. So 152.5 would be my greatest. The lower bound is 151.5, but I don't need that today because it's asking about greatest. If I do the same then for 102, 103 that side, 101 that side, and then put my dashes in, and 102.5 is my upper bound there. So I go 152.5 and 102.5. If I want to find the area of a rectangle, I got to times these two together. That gives me 15631.25 millimeters squared. We got estimated mean now. Calculate an estimate for the mean number of pages per paperback book. Now we've got to be really careful on this one. We got this space here, and we know we got to add in our two extra columns. The first one being midpoint, and then this last one we normally call fx when we do 2 times whatever our midpoint is. The tricky thing in this one, which could cost us a mark, it wouldn't cost us all the marks, but it could cost us 1 mark, is what the actual midpoint is. They're tempted to say 50, because you see it going up to 100, but 50 would be the midpoint of 0 to 100. If we do like we do for median, and do 1 plus 100, tilt that up for you, 1 plus 100 equals 101, and divide by 2, we actually get 50.5 as being our median. So our midpoint here is 50.5. Do the same on the next one, and we get 150.5, and then 250.5, and so on. Now, if you missed that, they would only take 1 mark away. So if you had like 50, 150, 250, you'd lose a mark. You could still carry on to get the other 3 marks. What happens now, of course, we times these two numbers together to get our end column. 2 times 50.5 gives 101. 6 times 150.5 gives 903. 16 times 250.5 is 4008. And 34 times 350.5, 11917, and then last 12 times 450.5, 5406. Big numbers, but we are talking about pages in books and multiple books in some cases. Now, mean is when you add them all up and divide by how many there are. This is the column to add up. Be really careful that you're typing in your numbers correctly. And they all come to 18727. And then divide by how many there are. Don't make the mistake of dividing by 5 because there's 5 rows. Right? There's 2 clues here. We've got 70 books. Tells us in the top question there we've got 70. And also if we added up this column for number of books, we'd also get 70. So we want to do 18727 divided by 70 to get our answer. And that comes out to be 267.5 pages. And we expect our answer to be roughly in the middle, which is great because it does. Comes in the middle. Guinevere has bought an e-reader. Her e-reader can store the equivalent of 1100 books. Calculate an estimate of the number of pages stored by Guinevere's e-reader and give our answer in standard form. Well, she's got 1100 books, right? We've just worked out an estimate of 267.5 pages. So times by 267.5 as a rough estimate, that'll come out to be 294,250. So 294,250. In standard form then, that's 2.9425 times 10, 1, 2, 3, 4, 5 times 10 to the 5. Don't forget that extra little 0 on the end, giving us 10 to the 5. It's not just 10 to the 4. And then we're on to our last page. We got a right angle triangle, and we got to find a missing side here, which is a hypotenuse. So calculate the value of x. We're going to do Pythagoras. We're going to square 8.4. We're going to square 6.7, and then we're going to add our two answers together to start with. 8.4 squared comes out to be 70.56. 6.7 squared comes out to be 44.89. Add these two together, get 115.45, then square root that to get our answer. .74 centimeters. A little bit of trigonometry to finish then. Calculate the size of angle y. As you know, you've got to label up the sides first. So you need to know your adjacent, your opposite, your hypotenuse, etc. Let's start off by doing that then. So I've got opposite the angle. Hypotenuse I've just calculated, and I've got the adjacent here. Now because I've actually found the hypotenuse, I could use any one of the three trig ratios, but I'm inclined to use the ones they've given. They've given me O and A, and I've got to find this angle y in there. Now if I think about O and A, how to SOHCAHTOA, that's going to be using TOA. And normally I just do tan of my angle and press equals to get my magic number, but that's the thing I've got to find, y, tan y. So what I've got to do is work in a different way. I'm going to tell the calculator the magic number, and it's going to give me the angle that y is, so we're going to go backwards. Now OA is opposite over adjacent, and my opposite side is 8.4 and my adjacent side is 6.7. So 8.4 over 6.7. 8.4 divided by 6.7 comes out to be 1.254. Remember what I said, 3 decimal places minimum for this. So that's the magic number. Now I can tell the calculator that if I press shift and then tan. If I put that in shift tan, your tan to the -1 comes up, and we can put in 1.254, press equals, and it works backwards to tell us then that 51.4 degrees is our angle. I went a bit quiet there because I think I realised I'd made a slight addition error here. I missed out one of these numbers when I was adding everything up. I should have came out with 22335. So this total was wrong. Sorry folks. 22335. I'd missed a number, which of course then affects this. 22335 divided by 70 is 319. 319 pages is 0.07, so I think we can call it 319. And of course then that means that this needs to change as well, so I'll just get rid of that. 1100 times 319, so that to start with comes out to be 350900, and if that's in standard form, that's 3.509 times 10 to the 5. 1, 2, 3, 4, 5 as before. Sorry if you spent a long time looking at that. I think I missed out the 5406 because I'm a little bit out somewhere, or the 4008. Okay, that's that then. That paper is complete. Now if you've got any questions at all, remember, go through it. On the front you can write down some of your strengths, the topics you did well on, and any targets then you want us to go through in class after Easter. Use your maths watch as well to find those types of topics, and see if you can do your best over Easter, but we're there to help you then when we come back. Best of luck with your revision.